Hi, welcome to this session on Azure VMware Solutions. My name is Sai Chaitanya. I'm part of the Azure dedicated engineering group and work in the program management team here. As you know, Microsoft Azure is the trusted cloud for most customers today. Customers run their business critical applications, their modern container-based applications, and a variety of other data intensive applications on the Azure infrastructure. The Azure infrastructure is built on top of Azure Compute, Network, and Storage. However, as customers have tried to shut down their data centers and move to the cloud, over the years, they've been telling Azure that there are workloads that don't necessarily fit very well into the core Azure Compute offerings. These are apps and workloads that need maybe access to bare metal infrastructure. These could be applications that are running on purpose-built hardware, and so on and so forth. To solve these needs of customers, what Azure did in the recent years was we spun out a dedicated engineering group, and that's internally called Azure Dedicated, to come up with a number of solutions and services to meet these offerings. Today, we have these offerings that you see on the right, where VMware as a service, SAP as a service, NetApp, and so on, that are all running on dedicated specialized infrastructure as an extension to the core Azure Compute services. Azure VMware Solution is an offering built by Microsoft. It's a first-party Microsoft service that lets customers run their VMware private clouds on Azure infrastructure. So what customers really get here is the ability to provision a full stack VMware cloud that includes VMware's compute, network, and storage stack on top of Azure's infrastructure in a region of their choice. This service is built, supported, and operated by Microsoft. However, it is done in deep partnership with VMware. So as we've been engaging with customers with AVS, there are a common set of scenarios that customers most often use. The first and foremost one is really data center expansion. As customers go cloud native and where they want to basically run everything in the cloud as their preferred choice, what we see as a very normal pattern is customers now do not want to build additional data centers. They might not want to choose to go build additional racks of infrastructure in their existing data centers. What they instead want to do is to provision all new infrastructure in the cloud. So data center extension or expansion is a very, very common use case for Azure VMware solutions. What we also see in some of our extremely large customers and even in some of our mid-sized customers is data center evacuation. While data center evacuation is a long-term and an intense process, we certainly have a significant number of customers who are on the early stages of that journey to completely evacuate their data centers. And given that almost all of these customers run a significant portion of their workloads on VMware in their on-premise architecture, they are looking to use VMware on Azure, which AVS enables. The next common use case that we see from a lot of our customers is disaster recovery. So what we learn from customers is the cloud enables the enterprise customers to bring disaster recovery to some of their not just critical infrastructure, but even other business critical applications. So today, enterprises typically implement disaster recovery for their mission critical systems, but some portion of their business critical applications, which are of little lower priority, don't necessarily have the protection that they need. And the cloud enables this in unique ways. The fact that you can store large amount of data in low cost object stores in a highly scalable fashion, and the fact that you can spin up compute nodes in a very elastic fashion as you need them in times of disaster really enables customers to expand the scope of disaster recovery to a greater portion of enterprise applications. And that's a very, very common use case that we see day in and day out with AVS. The next thing that we see is application modernization. So as most of you are aware, Azure has extremely differentiated platform services like Azure IoT, Azure AI, Azure Big Data. which enable customers to go build unique insights, differentiated services that they were otherwise not able to do in the past. However, given all of enterprises' critical applications run on on-premise data centers typically and on VMware, and the fact that these cloud services are extremely distributed, running far away in the cloud, really hindered some of the adoption of these use cases. But the fact that AVS is running VMware workloads inside an Azure data center, and the fact that these are tied by a high-speed Azure network backbone, we're actually able to bring the goodness of all of Azure's next generation AI, ML, big data, IoT services to the enterprise application base of, you can say, the world. So with that, the Azure VMware Solutions is composed of the compute, network, and storage stack from VMware. And these are ESXi for compute, vSAN for storage, and NSX for networking. Azure VMware Service is a first-party Microsoft service. And what the service entails is the elements of VMware's compute, network, and storage stack. ESXi for compute, NSX for networking, and vSAN for storage. So as a customer buys an AVS node, what they're getting is the full stack of VMware software in addition to the physical bare metal node. In addition to these benefits of provisioning VMware stack on Azure infrastructure, AVS also entitles customers to Azure hybrid benefits. Almost all VMware customers run Microsoft workloads, be it Windows Server or SQL Server. So as customers move their Windows Server or SQL Server workloads from on-premise VMware infrastructure to the cloud, the Azure hybrid benefits are also applicable to those customers. In addition to that, we're also extending the benefits of extended security updates that we offer for Windows 2008 VMs moving to Azure Compute, also to AVS. Microsoft is the single point of support for all of the AVS service. So what that really means is as customers have issues either with their physical servers or their compute stack or their networking service, they start by interacting with Microsoft. Microsoft is the single point of support. As Microsoft needs additional extensive help, we actually have a deep partnership and engagement model with VMware, where we're actually able to leverage some of their engineering services. In addition to the compute, network, and storage stack, an AVS customer is also entitled to what a service called HCX. HCX enables cloud mobility or migration of virtual machines or vSphere virtual machines or VMware virtual machines from one VMware infrastructure to another. So almost all AVS customers end up using HCX, and it's used to move virtual machines from an on-premise VMware cloud to the AVS. We've also innovated on top of the VMware's core stack. We've extended the NSXs by providing a Azure portal consumption experience. So customers can go into AVS portal on Azure and actually configure networking and security constructs on NSX. We did this because what we learned was some of our customers had limited exposure to NSX, and getting started with NSX was a little challenging for compute admins and for developers. And there was a big value in simplifying the NSX experience. And so we've gone ahead and added that capability. All of the AVS infrastructure runs on extremely high performance nodes, which is primarily backed with a lot of Intel infrastructure. So most customers, when they deploy an AVS environment on Azure, they end up connecting that environment to an on-premise data center. And the way to do this is either using an express route infrastructure that Azure customers are familiar with, or using a VPN service that's part of the AVS stack that allows customers to provision IPsec VPNs from their cloud environment to their on-premise infrastructure. So let's talk a little about AVS's stack in a little more detail. When we provision when a customer provisions an AVS private cloud, what ends up happening behind the scenes is we provision the latest VMware software on top of their dedicated bare metal nodes. We provision ESXi 6.7 U3. We use NSX-T's almost latest version, which is 2.5, and we use HCX. We also provision the HCX manager as part of the private cloud provisioning. And all of this VMware software stack is provisioned on extremely high performance compute infrastructure, which I just spoke about a bit. And what's really under the hood we have the latest generation Intel nodes, which basically are running where each node has 36 cores. We enable hyperthreading, so what you really get there is 72 CPUs, and these machines have the latest generation disks. So you get an all-flash infrastructure, and where we provision vSAN. And for those of you who are familiar, vSAN has a two-tiered architecture where there's a caching layer, which needs to be more performance intensive, and then there's a capacity layer. In AVS, the caching layer is provisioned with NVMe-based SSDs, and the capacity tier is provisioned with SATA SSDs. In addition to that, we have extremely high network redundancy to each of these bare metal nodes. So we have 100 gig going to each physical host, and where we basically use 2 physical NIC ports for running all of the management traffic to the node, which includes like vMotion, vSAN, etc. And then we have 2 physical ports or 50 gigabits of allocated for workload traffic. When a customer provisions an AVS private cloud, we deploy the latest generation VMware software on top of this infrastructure. We use ESXi 6.7 U3 for the compute nodes. Is the same for vSAN, and for NSX-T we provision to NSX-T 2.5.2. We also deploy the HCX manager as part of the private cloud deployment process. Any customers who are looking for an upgrade from HCX Advanced to Enterprise can also avail that service. The VMware private cloud is deployed on top of the latest current generation server infrastructure. Each of this physical node has 36 cores, which are based off Intel CPUs, and we have 576 gig of RAM on each of these nodes. And the AVS's implementation of vSAN is an all-flash architecture, which means that both the capacity tier and the caching tier are based off flash hard disks. The capacity tier is based off SATA hard drives, and the caching tier are based off NVMe hard drives. We also have extremely high network redundancy to each bare metal node, where we have 100 gigs of network bandwidth provisioned to each bare metal node. 50 gigs of this is dedicated to management traffic, and the other 50 gig is for workload traffic. A customer can buy an AVS node either on a monthly basis or on a yearly basis, or they can additionally also buy this in a pay-as-you-go manner. When a customer deploys a private cloud, the minimum number of nodes that they need to deploy is 3 nodes. And HCX Enterprise is an add-on that they can optionally choose. And many of our customers do end up choosing HCX Enterprise as it enables cloud migration at massive scale and performance. While the minimum number of nodes is 3 nodes, we today offer this infrastructure where you can actually deploy up to 16 nodes in a given vSphere cluster. And the ability to go from 3 nodes to 4 nodes is an extremely simple process where you can scale your infrastructure by going to the Azure portal, where you can go to the portal, go pick up a cluster, and you can either shrink the cluster down or expand the cluster to additional nodes. Today at GA, we support up to 64 nodes in one AVS private cloud. So once a customer deploys an AVS private cloud, they then have access to the familiar tools that they use to manage VMware infrastructure. That is vCenter for managing all of the compute and storage, and NSX-T Manager for managing the networking environment. Today, we're working on certifications for the AVS service, and we're working on all the certifications that are relevant to a lot of our enterprise customers, to our government customers, and also for specific verticals like financial services and healthcare. Today, we're working on ISO certifications SOC certifications and FedRAMP certifications, and all of these certifications are available at GA. So in addition to deploying the VMware infrastructure, the AVS service is responsible for keeping all of the infrastructure healthy, which means that we're continuously monitoring the software stack and the hardware stack for failures. We look for failures in various things like disks and physical network interface cards, network switch ports, power failures, and a variety of other things. So AVS is continuously monitoring and repairing the infrastructure. So the customer, the moment they deploy their private cloud, they're free to kind of go deploy virtual machines and use the infrastructure, but keeping the environment up and running is something that the service actually does for them. And Microsoft is the single point of support for any issues that arise, either in the physical layer of the stack or in the software or the VMware layer of the stack. So customers, when they have issues, they would start by creating a Microsoft services ticket, and then we would go and troubleshoot the environment. We actually have a lot of folks who are now deeply trained and have built up this experience on this VMware infrastructure in addition to the existing Azure skills. And all of this program is actually certified by the VMware Cloud Verified program. And we do have the ability to go and leverage VMware support when our troubleshooting teams are not able to root cause and fix the incident. So now let's go ahead and look at some of these areas in a little more detail. So let's start with compute and storage. So we looked at the AVS private cloud at a high level, and we said that it's composed of vCenter, NSX Manager, and the ESXi and vSAN and NSX-T. So when a customer goes and deploys a AVS private cloud, what happens behind the scenes is customers, the Azure AVS RP is basically going and picking a few set of nodes from the available pool of nodes in that region, and then creating a dedicated network environment for the customer. So they get their own private network, they get their own servers that are dedicated to that customer, on top of which we actually install the private cloud environment or the VMware software stack. And then what we also do is we connect the customer, we give the customer the option to connect the VMware private cloud to the Azure Compute environment, where customers might be running other services like Azure Virtual Machines or Azure Containers or other platform services of that nature. So, and then AVS is also continuously, as we said, monitoring this environment and is responsible for repair and upgrade of this environment. So customers do not, unlike on-premise VMware infrastructure, customers do not have to worry or take the pain of upgrading this entire VMware stack, which is composed of many elements, and the AVS control plane does that for them. So when a customer goes and deploys the private cloud and starts using the private cloud, they need to start by accessing the vCenter. So for that, what administrators typically do is they need to go into the AVS portal and they need to fetch the credentials for vCenter and NSX Manager, which they're able to go do. And then they're able to go and deploy virtual machines. When AVS detects failures at any parts of the stack, we actually repair the servers or repair these nodes. And part of this is done by completely automated systems, and part of this is done where and in situations where automated systems cannot completely repair the infrastructure, we have mechanisms where we have SREs get involved and repair this infrastructure. So customers will also have this ability to configure log forwarding, where they can forward logs from their SDDC appliances into Azure Monitor or Azure Log Analytics. Most administrators or VMware deployments on-prem use vRealize operations, and vRealize operations is used as a mechanism for monitoring the and troubleshooting the VMware stack for a very long time. So customers can continue to use their existing vRealize operations to monitor their AVS environments. We have a couple of deployment options. One option is where customers run vRealize operations on-prem, and they point it to a AVS environment that's running in cloud. The other deployment option is where they can deploy a brand new vRealize operations environment on top of AVS. AVS comes with an SLA of 99.9% availability. And this SLA, what it really means is AVS is continuously monitoring and keeping these three elements, which is the SDDC VMware management VMs, which includes NSX and vCenter, up and network reachable for 99% of the time. In addition to that, what AVS also does is it ensures that there is connectivity and uptime for all of the guest VMs running on top of AVS for 99.9% availability. However, to go get this SLA, customers are required to maintain few conditions, and the most important one is basically to make sure that there is sufficient free space in the vSAN layer of the stack. So that is something that's very important. So with respect to maintenance, the control plane or AVS service is responsible for applying patches and also upgrading the stack. So patches is a mechanism where VMware or any of the hardware vendor that releases new versions of software that fix bugs or some security issues. So patches typically don't come with new features, but they're typically a means to go fix bugs or some security issues. And then these vendors also release minor and major software versions. So VMware basically, as VMware releases these patches and versions, AVS consumes these patches and new software versions in a cadence. So the idea really here is basically we would try to patch the environment once in a quarter, and then the upgrade frequency will be a little lower. So as we go and do these things, we basically notify customers when we are going to upgrade their stack, and then customers can then plan maintenance times within their own enterprises. As we go build AVS, we're also introducing some new features post GA, and some of the key ones really is placement policy. Placement policy is the ability to define policies where you can define certain virtual machines need to run on specific number of hosts, and we want certain virtual machines to always run on different hosts. So we have a number of use cases where customers would like to define policies either for their virtual machines or for their physical servers or both. And placement policies is a mechanism to do that. We also have some other features like custom core counts, where to enable scenarios where customers do not want to have all the CPUs on the physical server to be active. So a lot of enterprise applications are licensed by cores, and customers would not like to exercise or use all of the cores on a physical server, and that's a feature that is enabled by custom core counts. AVS comes with a default user and role, and it's called Cloud Admin. So the Cloud Admin role on AVS enables a customer or a tenant admin to deploy virtual machines, create virtual machines disks, create snapshots, and do all operations with respect to what's required to provisioning VMs and applications. The Cloud Admin does not allow operations for managing the vCenter infrastructure. And for example, it does not allow the operator to perform upgrades or remove nodes or reboot nodes on those type of operations, which are all in the responsibility domain of the cloud operator. So in addition to the Cloud Admin role, there is also a local user that AVS comes by default with, and that local user is also called Cloud Admin. But most enterprise customers would like to basically use their existing on-premise Active Directory users and their usernames and passwords for accessing vCenter. And that's something that we can enable by configuring an Active Directory domain with the AVS SDDC. vSAN is the default storage stack for the AVS private cloud, and vSAN is based on hyperconverged architecture. Hyperconverged architecture is a generic industry term for a solution which pools physical disks from multiple physical servers and makes a logical storage volume out of it. And vSAN, which runs in the core ESXi stack, implements an HCI solution. And vSAN has a two-tiered architecture, and the capacity tier is primarily for storing all of the virtual machine disks, and the cache tier is for storing all of the hot data. So the idea really is you basically have a cache tier where you can have all of the blocks of data that you're accessing more often, and you typically might implement a more expensive and high performance disk for the cache tier, and then your capacity disk is more optimized for volume of storage. So today each of the node comes with 3.2 terabytes of cache disks based on NVMe and 15 terabytes of data for the capacity tier. vSAN comes with a number of key features which are extremely valuable to customers. Encryption is one of the most important feature. So all data on AVS is always encrypted, and this is accomplished by using the vSAN's encryption feature. Anytime a customer creates a virtual machine on an AVS node, the data is always stored in an encrypted fashion. In addition to that, customers can also configure additional policies using vSAN's storage policy management interface, where they can basically define how many failures you want to tolerate, what kind of replication mechanism you want to use, which can define how fast you recover data, right? And so on and so forth. The key thing with respect to vSAN when using vSAN on AVS is to always make sure that you have sufficient free space or slack space on the cluster. If a customer does not maintain free space or slack space in the cluster, it basically leads to a situation where the operator might not be able to perform the typical day-to operations like rebooting the nodes, removing and adding new nodes into the cluster, or upgrading nodes. And it leads to a situation where the operator cannot guarantee the SLA. For a customer to have an SLA or to be SLA compliant, they always need to make sure that there is 25% of free space on a vSAN cluster on AVS. So with respect to roles and responsibilities, right? So there are three primary aspects, right, with respect to deployment, lifecycle, and configuration. So think of deployment as your day zero provisioning. Lifecycle is all of your day two operations, and configuration is where you deploy either policies, deploy virtual machines, and so on and so forth. So with respect to deploying virtual machines, applications, and running OS, configuring the operating system for each of the virtual machine, that continues to be in the realm of the customer. So a customer would bring their OS, bring the license for the OS, deploy an application, deploy virtual machines, and those are all in the realm of the customer. But when it comes to basically deploying the physical infrastructure, right, deploying the compute network storage stack, upgrading the infrastructure, repairing the infrastructure, and managing physical security, they're all in the responsibility domain of the service operator, which is AVS. So we've touched upon HCX a little earlier. HCX is basically a mechanism for migrating virtual machines from one VMware environment to the cloud. What it can do is it can basically move virtual machines from disparate versions. So even though AVS runs the latest 6.7 software, as customers might be running various versions of VMware on-prem. So we have most of our customers are running 6.5, and some customers are running even older versions. So as customers would like to move those virtual machines into the cloud, they typically deploy HCX. So every AVS private cloud comes with the HCX manager pre-deployed. So these customers would then have to go and deploy HCX in their on-premise infrastructure and then go configure HCX peering between on-prem and cloud. And then they're able to go and exercise and use HCX's bulk migration feature. and that lets them move many virtual machines um, without any downtime. So for customers who want to move bulk VMs with no downtime, they can also avail this additional feature called replication assisted vMotion, which can be availed using the HCX Enterprise add-on. So for a lot of customers, as they move VMs from one environment to the other, they need to extend their layer 2 network, because vMotion assumes that the same layer 2 network is present between the source hypervisor and the destination server. So HCX has the capability to not just replicate the virtual machine and vMotion the virtual machine, but it also has the capability to extend layer 2 network all the way from their on-premise infrastructure into the cloud. With respect to networking, the primary SDN stack or the networking stack for the AVS virtual machines is NSX-T. And NSX-T can be used to configure virtual networks or logical switches or segments. It can be used to configure firewall rules, load balancers, and customers do have full access to the full NSX-T user interface features, and they can configure anything that NSX-T supports. With respect to connectivity from AVS environment to the on-prem, most of our large customers typically deploy ExpressRoute, and they also configure global reach to connect from the on-prem ER to the AVS ER. AVS is connected to the core Azure infrastructure internally with an ExpressRoute connection, and that is a service managed ExpressRoute connection. And for anybody who wants to connect two environments and a couple of environments that have two ExpressRoute connections in between, they typically use global reach. In addition to ExpressRoute, we do also have a lot of customers who actually use site-to-site VPN. And so as customers are just getting started, or they're doing POCs, or even if some of our smaller and mid-market customers, they all use site-to-site VPN to go and connect their on-prem environment to AVS. So AVS relies on using Azure VMware technology to connect their on-premise infrastructure into AVS. Now, HCX has a requirement for ExpressRoute. And when HCX is used over VPN, there are a number of limitations. And those limitations primarily is that HCX can only be used for POC purposes on top of VPN infrastructure, and cannot be really used for moving production workloads to over VPN infrastructure. In addition to that, we also basically have the ability to connect a AVS private cloud to a customer's VNet. So customers might be running a bunch of Azure Compute VMs, Azure container instances inside the VNet, and these applications might need to talk to, let's say, in a database running on top of an AVS node. So what we do have is an ability to connect the AVS private cloud to the customer's VNet using ExpressRoute. We also have public IP support, and the public IP support allows customers to configure public IPs for AVS instances. So if you want to deploy an application and expose that application directly to the internet, we do have the ability to configure public IP. We also have the ability for L4 DNAT, which is the ability for AVS VMs to reach out to the environment, to the public internet. With respect to backup and disaster recovery, Microsoft Azure Backup Server is used by a lot of customers with AVS. Azure Backup Server is freely available with Azure Backup and allows customers to back up virtual machines and applications running inside those virtual machines. Microsoft Azure Backup Server is a backup solution that is freely available to Azure Backup customers. Azure Backup maps can be used to back up VMware virtual machines and also applications running inside those VMware virtual machines. It works using standard VMware APIs and works using VMware snapshots. For disaster recovery, we have two options. AVS customers are entitled to use HCX, and HCX has built-in disaster recovery capabilities. So customers can configure HCX to perform storage replication which is where you basically copy disks from your primary site or protected site to a recovery site. And then at the time of disaster, you can actually fail over your primary virtual machines, your virtual machines from your primary site to the disaster recovery site. Customers can also use Site Recovery Manager, and Site Recovery Manager is a solution from VMware and relies on vSphere replication. SRM, or Site Recovery Manager, leverages vSphere replication to replicate a vSphere virtual machine's disk from an on-prem VMware node to a destination or AVS cloud VMware node. So customers, SRM is not part of the base AVS service, and customers need to either reuse their existing SRM licenses or purchase the additional SRM licenses to go configure disaster recovery. With respect to disaster recovery, we have two common use cases. One is where customers would like to protect on-prem primary site and use AVS as a DR site, as a recovery site. The second use case is where customers are running their production workloads and AVS is the primary site, and you're trying to recover these applications and VMs in another AVS site, which may be in a different region. In addition to MABs, HCX, and SRM, we're also working with a number of partners. So for backup, we're working with Commvault, Veritas, and Veeam. But for disaster recovery, we're working with Zerto and Jetstream. And these are partners that will be validated very soon with AVS. We've also validated GitHub Server. And GitHub Server can be installed and be used by DevOps teams using AVS infrastructure. With that, I'd like to also call out that Microsoft was awarded recently the Global Partner of the Year for Technology Innovation recently. And this basically is testament to the close partnership we have at all levels, engineering, product, sales levels, and support to go build these solutions. And we look forward to more close collaboration. With that, feel free. I encourage all of you to look for more information about Azure VMware Solutions on the Azure portal. We have a number of resources, like in terms of getting started guides and a lot of videos for getting started. And I encourage all of you to look at this. Thank you.